Hello and welcome to Sean White's Solar and Energy Storage Podcast. In this podcast, we have Matias Sigal, and he is from Replace. He's going to tell us all about the development process of big, giant solar projects, and we're going to get into it with him. Hey, Matias, what's going on?
Hi, Sean. Thanks for having me here.
Thanks a lot. And what we can start off with is having Matias Sigal introduce himself, tell us a little bit about his background, where he came from. I was checking out his LinkedIn page, and he's got quite a history of entrepreneurship. And so that's interesting to me. It's always interesting to me how people got into the solar industry. He's good at startups, I think, and things like that. Matias, tell us about yourself and about Replace, your company.
Sure. I'm Matias Sigal. I was born in Argentina. Since I'm very young, I started to learn that I wanted to be an entrepreneur. And then, after starting a few things since I'm 13 years old, I learned that I wanted to make an impact. Not only make a company, but also make an impact. And this is when I learned about climate tech and also climate change. And I decided...
Wow, when you were 13, huh?
Later, at 13, I started to become an entrepreneur and I did a few businesses. If we have time, I will mention them. But also after that, let's say 5 or 6 years later, I learned that I want to make an impact. And I had, in fact, a company. It was non-tech, but it was a company, and we started to make social impact. We were building some products that were like made of textile, and we started to build it in a factory of ex-convicts that they went out from jail and they couldn't get a job.
Ex-convicts, is that why you picked me? Just kidding.
And there I learned this combination of business and impact, but I learned about a bigger problem, which was climate change.
Okay,
and
great.
That's how I entered in the ecosystem.
Yeah, I've done some classes myself, and we call them returning citizens. That's what we call them, the nicer term, I guess you could say, in the US that we've been using lately. Great.
So it was very interesting, and I hope we could help. But now changing topic, like at that point I discovered about this other side that was climate change, and I think in my head was, okay, here you can match perfectly economic growth with impact, in this case reducing CO2 emissions and helping, let's say, achieve an energy transition. I needed to learn much more about it. And I decided to go to Israel, not only to learn about renewable energy, but also to learn about startups, because I wanted to build something global that makes an impact.
Great. So when you moved from Argentina to Israel, how old were you?
At that point, 21, now
21?
26.
Oh, okay, young man. That's nice. Great.
I decided to go to Tel Aviv to work in a startup in the renewable energy sector. But I was going only for 2 months to have an experience and come back to Argentina to continue working from there. But 5 years passed since then, things changed. And what happened was that the CEO of the startup I was working with offered me to go to Europe to open the company through an accelerator program. It went really well, and I ended up going to 6 accelerator programs all over the world in
6
the
accelerator
Netherlands.
programs.
Netherlands? Accelerators and incubators, Netherlands, Australia, Portugal. I got to feel the tech ecosystem in these different countries and continents, but also the renewable energy ecosystems, because I was doing two things, like developing projects, but also opening a startup, because the startup was developing projects for this innovative technology. And this let me learn a lot about the problems in the industry, because in my head, the goal was to learn, to then build my own startup that makes an impact on the environment, as I was saying at the beginning.
That's pretty neat. And you've gone through all these startups and incubators and things like that, and you got to see the world at the same time. I like doing that myself. My job includes a lot of travel. I probably travel about a third of the time. And that's a great way to see the world while you're working, while you're saving the planet, instead of just going to a bunch of tourist attractions.
Yeah, exactly. And you get to meet people. It's amazing.
Yeah, instead of just meeting a bunch of tourists. It's like you go to Europe to meet a bunch of Americans, or for somebody like me.
Yeah.
Great. That's pretty neat.
And this is all, if you want, I complete the circle, because this is all combined. Like I was telling you that my goal was to learn about startups and renewable energy. And this is amazing because I was inside an ecosystem, for example, in the Netherlands, we were 15 companies. I was not in that company, but most of them were the CEOs of the company. So I was learning from them. And I
Hmm.
started to think, okay, I will start to evaluate problems and technologies in the climate tech industry in order to find an idea, to find a big problem that technology can solve and build a company around it. I thought, okay, this idea won't come from the trees. Like it won't fall like the apple to Isaac Newton in the head and we'll discover gravity. I need to
Hmm.
pursue it. I need to try to find this problem that is big enough and important enough for me to build a company around it. And I started to do something I call the Startup Monday. So every Monday after office, I didn't do any social plan or nothing apart from studying technology, studying problems, evaluating solutions. I did this for 2 years. I evaluated 52 problems, and any of them was good enough until I had a problem on my own, that a problem that I was having in my job. And then I continued with that problem, and that led for Replace to start.
Great. Okay. How about replace? How can we explain to people what replaces or what replace does? I think it's RE for renewable energy, renewable
Exactly, you
energy
got it
place. Yeah.
perfectly. You got it
Uh-huh.
perfectly. So it has double meaning. And in fact, my dad came with the name while I was telling him about the idea. It means renewable energy place, but also replace because we want to replace fossil fuels with renewable energy. What
Great.
we do is we help energy companies identify the best location to build a renewable energy project in one click.
You help people find the best places to build a renewable energy project. And I believe you're talking about big projects. Like what size would be the smallest? You're talking about like utility scale ground mount, right?
Mainly, yes. However, we can help different types of developers working on community solar. In this case, will be smaller projects. We can help also on agrivoltaics. In fact, we do
Hmm.
have a project with agrovoltaics that is putting solar panels on top of agriculture without
Hmm.
taking the agriculture. And it's something that is booming in countries with not so much available land like the US. So in the US, it's not that big, but in Italy, Israel, and other countries is very interesting. And
Hmm.
also the main goal is to work with utility scale developers doing greenfield solar, as you said.
Okay, so the main is for utility scale. I think what we should do is we should identify what community solar and agrivoltaics are. And I know when you said community solar, you said in smaller projects like community solar, but how big? It's not like 10 kilowatts or something like
Yeah,
that.
yeah, yeah.
What community solar is to get a community, of course. And I say I live in an apartment building or something like that. What they can do is they can put a solar project on the other side of town, and then people that are renters, people that can't put solar on their roof and stuff like that, they can participate as it was if they did have it on their roof. Does that sound right?
Yeah.
And not to be confused with community choice aggregation. And that is actually what got me into solar. It's called a CCA, and my friend wrote the CCA law. And I have a podcast that I did a few years ago with him that if people want to listen, and over 10% of the people in the United States, so that's over 30 million people, get their electricity through a CCA. And so everybody should get that. And pretty much what they do is they decouple the electricity from the power lines and transmission and all that kind of stuff. So the utility still gets to participate, but they don't purchase the electricity. They just can transmit and distribute the electricity. I'm simplifying it, but just trying to let people know what that is. And it's different. A CCA, community choice aggregation, is different from community solar. Let's try to even just guess at what size, approximately, throw out some numbers. Community solar, when you said it's smaller, like you're talking megawatts, probably.
Yeah, let's put it like this. In my mind, when I was saying smaller, I was talking about between 1 and 10 megawatts, maybe up to
Hmm.
20. That's better than me. It depends on the regulation in each state and in each country. That's how also it can be defined.
Hmm.
And in
So,
agrivoltaics, we are also talking about between 1 and 10 or 20. However, the technology is very, let's say, scalable. And what I mean here is that we can also adapt the technology to be able to service additional renewable energy technology. So we have in the pipeline to include wind, for example. And with
mhm.
this same thesis, we can work with different sizes of projects. However, the algorithm then needs to be adapted because if you want a smaller project, you need less land. but also the regulation is different, the grid connection is different, everything is related to the size. So I
Hmm.
agree with you, it's very important, but we are very flexible. We set it
Okay.
in a way, however, we are open to work with different type of sizes.
Yes, because one of the things that I've found is that although rooftop residential solar is a small amount of the solar that goes up, it's probably like utility scale solar, and if you include anything over a megawatt that's on the ground, things like that, including community solar, is about 2/3 of the solar in the United States. And the rest of it is rooftop. Some of that's commercial rooftops, residential rooftops. But everybody, when they think of solar, they think of like, I'm going to put 20 of these things on my roof. And you're talking about thousands
Yeah.
and big things, going to big transformers, going over power lines and things like that, not talking about putting up a few different solar modules. So that's not what your business is about, but most of the solar business is not rooftop solar. And I don't have the numbers for other countries and things like that, but I think probably the percentage of rooftop solar in the US is bigger than most places. I would be surprised if some place like China even has 5% of their solar being on rooftops, or at
Yeah.
least residential rooftops. It might be somewhere, I don't know, 1%. If I had to just take a wild guess, I'll have to go look that up and let people know a different time. If I can find that information, I can't, sometimes you can't trust your source. I got to call
No,
Xi
of course.
Jinping, ask him.
But also makes sense because utility scale solar, I see it like I compare it a lot when I try to explain from people outside to people outside the industry that is like a real estate project. That
Hmm.
you find the land, you design the project, then you get the investors and you operate it for 25 years and you get revenues from selling of electricity. In the real estate case, will be renting the apartments, for example. This way, you can finance it partly with the bank, with a loan.
Hmm.
And then by definition, you can build like in total more megawatts than the way where each rooftop owner needs to decide and be willing to make the project. Like here, it's a project that will provide profit to the investors, and that's how it's seen. It's the both are important, but utility scale solar brings a huge impact if it's done efficiently. And that's why we're focusing there, because we believe that by making utility scale solar more efficient, we will transition for a renewable energy future faster and better.
Okay. I'm sure there is way too much paperwork with these things. But what would you say the process looks like? I'm sure it's different in every case, but you find a bunch of land, and it's not the land that people see all the time. It's flyover land. That's where I've probably seen most of my solars from an airplane, because you look down and you see, oh, there's as much as a whole city. There's probably near Las Vegas. You look at that one project, there's got to be more solar in that one project that's on your way to Las Vegas than there is in all of Las Vegas, and like probably many times over. And people don't see it driving by, or not too often, because it's just off on a side road somewhere. How does somebody go about developing it? It's like, it's not something that I'm going to do. Would I need $1 billion to get started?
It's a great question, and I have a few things about it. So I will go in steps. First, there are 8 steps to develop a solar energy project. Like
Eight
summarizing
steps.
it, eight
Okay, great.
steps. You need to identify the sites, assess
It,
the site,
at least it's not as
develop.
they have a 12-step program.
I
But go ahead.
didn't know. But yeah, it's a process. So maybe summarizing is from identifying the site to decommissioning, you have 8 steps. The first one is identify, then assess, develop, finance it, operate, build it, operate it, and decommission. I made it in a summary, but mentioning the most important ones. And all those steps, basically, each time reducing the risk, and the big investment comes after finance, like when you finance it. So at
Okay.
the beginning, you need some funding for the development, to find the site, to do the engineering, to apply for the permits. After that, you raise the big amount, let's say, to put it in rough number, maybe $800,000 per megawatt, to actually build it. Where you need
So
to buy the
that's
panels, do the
uh-huh.
civil engineering, and there it goes the big money. And
So
then,
$800,000 a megawatt, that's 80 cents a watt.
yeah.
And so what is that paying for? That, like
So
everything?
basically, for solar,
Mm.
is a rough number of how much it
Yeah.
costs you to build a project.
Yeah, okay. I look at some different charts, and I know that you're global, but in the US, the latest charts are more like $1 a watt, something like that for a whole project. But maybe you build it 80 cents a watt and then you get to keep 20. That would be nice.
No, so I said a rough number, and
Yeah,
like
yeah.
it's a range because it's not the same if
No.
you build 200 megawatts and if you build 10.
Yeah, sure. And I'm sure too that, of course, we have tariffs and things in the US. You go to different places and it's a lot less. Like I would think probably in China, they're building it for less than 80 cents a watt.
Yeah, they don't need to import anything, and
Uh-huh.
of course, and the
Okay.
labor is cheaper. Of course,
Mhm.
like the labor, it also comes inside the total capex because
Yeah.
in these 8 steps I mentioned, you go identify and assess the location,
Mm.
then you develop, you operate,
Mhm.
you finance, build, operate, and then the
Uh-huh.
commission.
And you used
So
a business term there too, and I just want to clarify it with some people. So you said CapEx, and so that means
mhm,
capital expenditures,
yeah,
and that would be like buying all the stuff to build the project. And then there's OpEx, and that's your operating expenses. And the OpEx would be more like O&M and things like that. OpEx for a coal plant is coal and maintenance and things like that. And so that's one of the big benefits of solar and renewable energy compared to other forms of energy is the OpEx is a lot less than for things where you have to just keep feeding them dead plants that have been dead for millions of years, fossil fuels.
yeah, exactly.
Let's see, we were going through some of those 8 steps, and then I would just got so excited about one of those earlier steps. And so let's see, I'll let you go on.
Yes, maybe just to say once again, summarizing the 8 steps to make it simple is to identify and assess the location. You find the location, then you make studies to understand if that location is actually suitable. Then you develop, meaning you make some studies, apply for some of the permits. Once you have all the permits, there are three main permits that are relevant, that are the grid connection approval, the environmental approval, and the land, like having a lease of the land or an option agreement or something similar.
So say that
And
again, the three different types of
yeah,
permits. So you're out there.
so it depends also where, like in which state and in which country, but in general, once there is something called ready to build project. A ready to build project worth money.
Uh-huh.
And it's tradable. Like some companies buy, they don't do the identify and assess steps, the first two
Mm-hmm.
steps. They just buy a project from another developer, which is usually in a ready to build stage. That means that they have three main permits: environmental approval,
Environmental
grid
approval,
connection approval,
grid connection.
and the land, the lease of the land or the
Yeah.
ownership of the land or an option agreement at least
What would you
for the
say
land.
might be the hardest one, or I guess it depends on the project?
It depends where, but all of them are key. And each time you have one of them, the project worth more money because
Hmm.
it has less risk.
Yep, yep. Okay. Yeah, and I
So
imagine
after
too,
you,
and I guess that's some of the part of what your business is doing is figuring out those three things, what it takes to get it. You can find a really nice sunny piece of land out in the desert, but if there's no transmission lines for 100 miles, you're out of luck.
exactly, the rough number is that 1 kilometer of lines, of cables, cost $1 million of capex, of capital expenditures, as we explained before. So
Wow.
if you are 1 kilometer closer, your investment is $1 million lower. If you are two, it's $2 million lower, and so on. The location is key. That's the thesis.
$1 million a kilometer, that comes down to $1,000 a meter.
Yeah,
That's wow. Okay.
it's a
That's an
lot.
expensive wire. I don't think I could sell wire for that price. People that are listeners out there, don't worry. The price of wire hasn't just gone up. We're talking about not just the wire itself, but it would be like transmission lines and all that kind of stuff and substations, things like that. But wow.
Going back to the steps, the first two steps, identify and assess, is where
Yeah.
we are focusing, is where replace is helping developers because,
Hmm.
first of all, you cannot change your location once you have it, and everything depends on the locations. The permitting depends on the location. The land, like finding the landowners and closing the deal, depends on the location. And the grid connection depends on the location. So the three main permits I mentioned depend on the location. And once you have a location, you cannot change it. That's your place. That's it. That's why we believe that making a huge study on understanding which is the best place to build a project gives a long-term impact on the project itself.
One of the things that I've heard people talking about too, different conferences and things like that, is a lot of the good spots are already taken. You have a place where you can build like a gigawatt, 1,000 megawatts, and there's
Mhm,
only so many of them because a lot of that
mhm,
has to do with transmission. And so, but you have a lot more places that can do 10 or 20 megawatts. And by the way, too, a megawatt, what would you say, like somewhere around 4 acres, half of that maybe, depending on the place. And that's and an acre to a hectare, because we have people that are not in the US where we use acres, there's 2.5 acres per hectare. So just another thing, make some flashcards, people.
mhm.
Yeah, so those are the things that people will be thinking about. So,
Yeah, exactly. We actually use those numbers for the
mhm.
algorithm. You said it perfectly.
Yeah, another thing too that's changing the game a little bit is the electric vehicles, bringing down the price of lithium-ion batteries. And then one of those places that we could put a certain amount of solar, maybe we could put twice as much because power lines aren't used constantly typically. They just go up and down. The average house in the United States is only doing 5 amps on average, even though we have a 200 amp service because we turn everything on all at once. It's not like we're just taking 5 amps continuously, but 5 amps continuously is over 10,000 kilowatt hours a year at 240 volts. That's the average house. That's just an example that I give to people that's a little bit more for smaller solar or something that they can understand. But that also goes for the big power lines too. And if it was too expensive to do energy storage, then you just have solar and it's going to peak out at noon. And you have to be able to handle that peak. And with energy storage, you can change that a bit, but it still costs, energy storage still costs money, but it's getting more and more prolific. And we can see how that can affect some of the economics that you're dealing with.
It's right you mentioned this because it's related to what you said before. You said that a lot of the good sites are taken for big projects and so on. And now we are mentioning EVs, which is an example of how things change. This is dynamic, like regulation change. The grid is upgraded and also it gets busier in some points. And demand change, like maybe there are new factories built. This is dynamic. And as a result, yes, it's true, some of the good sites are taken, but then you have to find the best good site available. And by definition, to find the best, you need to check all the sites. The problem that, going back to the beginning of the conversation, I told you I evaluated a lot of problems, but then I had a problem on my own. And the problem that I had was that I was developing projects, and few of my projects failed during development. I had everything. I had partners, I had a
Mm-hmm.
site, but then
Well,
with the
I mean, projects failing, that happens more often than not, right? Yeah.
80% of the times,
That's why I need $1 billion to start off to
it
play the
depends which
numbers.
size of project, but yeah,
Yeah.
you need some capital. And the 80% of the projects fail during development. In fact, I interview before starting the company 200 solar developers from every single continent in the world and every size. I interview billion-dollar companies. I interview two people companies. All of them, the 200 people I talked to, at least one example where one of their projects failed because of any of these reasons, the regulation, the grid, the landscape, or the landowners. That happens to everyone. Don't worry
Oh,
if
yeah.
some of your
Uh-huh.
projects fail.
And that's why I always say you need to be a big company where you can afford to take the chance or just play the numbers. So if you did 100 projects or you started to do 100 projects, that you would get 20 of them or something within a few of that,
Mhm.
where,
Yeah,
and then you could afford to do it and lose those millions of dollars for the projects that failed that you tried to develop.
yeah, exactly. These projects develop, talking again with the steps, they usually fail during step 2 or 3, like usually during the development where they discover that the site is not good enough before they invest the big amount. But as you said, they already invested quite an interesting sum. And the market, the renewable energy market, is losing billions of dollars per year because of these failures. Why? Because they make studies with engineers that cost money. They make trips, they pay option agreements for the landowners just to secure the land. And then they discover that land is not suitable because there is a regulation that it says that you can only build, I'm saying a random number, but you can only build X megawatts, X kilometer away from a city. And you are not fitting that criteria, so you cannot do nothing. You cannot use that land. and you just throw it to the garbage and start again with a new land. That's how it works today.
So you're going to save people how many billions of dollars?
It's a number that is difficult to calculate exactly, but we're saying that it's billions of dollars per year being
Hmm.
wasted on site selection because of this reason. And the other thing is that 80% of the projects fail during development.
Yep. So that's pretty good to get a few percentage of billions of dollars a year.
Yeah, to have another number which is not exactly correlated, in 2022, $500 billion were invested in building new renewable energy projects in the world, and this number is only growing. However, as we talked before, you need to develop a lot of sites per every site that gets built. So the development cost is not directly correlated.
Hmm. And so are you just focused on solar? Or, I know you mentioned wind. Are you doing wind too?
Today, we do solar and agrivoltaics, and we are starting to develop a project for community solar. However, in our near future, we are adding wind, hydrogen, and batteries, and different types of storage as well.
Okay, great. And we were also talking about defining agrivoltaics, and I think it almost doesn't need to be defined. It means agriculture and photovoltaics. Fortunately, sheep are white, so they reflect light, and maybe you can get a little extra performance on the bifacial modules that are over the sheep, right?
Yeah,
That's sort of a
yeah,
joke. But you never know. I'm sure there's to some degree, it's probably not a whole lot. They're not going to change any projects.
probably you are right.
But so it could be agriculture, it could be animals, could be plants, things like that. And sound about like it for you. And one of the things that we're seeing too is I live in a very polarized country, and some people are against solar just because other people are for solar, unfortunately. And they're trying to say in some places that the solar is taking up the farmland. And so with agrivoltaics, you could do both at the same time. And the farmers like it because they make money twice on the same acre.
Exactly. It's dual use of the land. It's extremely interesting, and we are talking about food and energy,
Mm.
which are like two of the big problems of our society,
Food and
com-
energy. Yep. Hmm.
and combining a solution for both. So it's extremely interesting, and it's just starting. It's
And it's cheap. It's not just food energy, it's also nice wool sweaters.
yeah.
So then we
Squeezing
got like we've
together.
got not just a dual use, maybe we could say we've got the three uses. I wonder
Yeah,
what if we
yeah.
could brainstorm and come up with some other uses too, but at the same time. Let's see, we got agriculture, photovoltaics. I don't know, maybe by the end we'll figure out something revolutionary.
Yeah, yeah. I'm trying to think as well. Maybe like also just to add regarding the going back, if you want for the site selection, we were talking before the agrivoltaics. I was saying that by definition, to find the best site, you need to check all the sites and then understand which is the best one. The thing is that manually or using GIS, Geographical Information Systems, which is the tool that most of the developers use, if not just they check the different layers of data like the radiation and the maps and the grid connection map and so on. Doing this manually is very complicated. Imagine maybe, for example, in Alberta, Canada, the province of Alberta, you have 2,100,000 lands. Let's say you invest 30 minutes
What
per
was that?
land.
2,100,000. What was that again?
2,100,000 parcels of land
Oh,
in one
parcels of
province.
land. Okay.
And I don't have the exact number in California or in Texas, but it should be something like that.
Lots of parcels. Yeah.
Lots of
I'm
parcels.
sure it's like that everywhere, probably, I imagine.
Yeah, because also there are huge parcels. In Israel, the parcels are much smaller. Also, you have more parcels per hectare.
Hmm.
My point is, in Alberta, Canada, you have 2,100,000 parcels of land. Let's say you want to check all of them and you will invest 30 minutes per parcel. This will take you 120 years.
Oh, okay, no problem. Yeah.
However, of course, you won't check all of them because some are cities, some are national parks. But my point is, any developer checks every single location, every single parcel of land with all the parameters because it's not viable to do it. But an algorithm can check every single parcel of land with all the relevant parameters. We are using 40 parameters, for example. And then the algorithm will define which is the best parcel for the need of the user. and it can also combine parcels to have a bigger size of land and so on. And this is the value proposition we are adding to reduce the risk of the project failing, but also to maximize the return of investment by finding the optimal location.
Awesome. That sounds like a lot of work coming up with the software, but it sounds like a great idea that could save billions of dollars. So just while we're at it, if somebody's there, where can people find, what's the website of Replace?
It's renewableenergy.place, PLACE.
Okay, great. Renewableenergy.place. That's interesting with all these new dots, dot something or other.
Because it's replace.
Yeah.
You got it at the beginning before I mentioned.
Okay, that sounds pretty neat. People can hone down and figure out where the best projects are going to be. And then you find some piece of land that works good. I guess you have to go figure out how to contact that person and things like that too, if you're trying to develop that piece of land. And I know that people talk about then get like purchasing an option, like giving somebody $50,000 for an option to develop the project that might not ever happen, things like that. So go ahead. I know we were talking about all these different steps, and they're just so interesting. We go into it, and back to you.
Yes, but I agree completely what you were saying. That's part of the process, and we want to streamline this process. And just in 2 clicks, the solar developer finds the land. So the developer uses our tool, and in 2 clicks, it finds the land that is the best land after checking all the potential lands with things like distance to the grid and permitting and topography and 37 other parameters that some of them are proprietary data that we build. And then the developer needs still to do their work and develop and then continue to the next steps. If they are also the operators of the project, they will build and operate and make money from selling electricity at the end of the story.
You know what it kind of reminds me of? Do you know Zillow? That where people look for houses and things like that. You're like the Zillow for developing a solar project. Instead of clicking like, I want to have 3 bedrooms and things like that, you can go on there and click what your criteria are perhaps for developing a project and then take it from there.
Yes, I love you mentioned that because we pitch to investors that what you just said. I want to confirm that I didn't mention it to you before. It's amazing that you came with the same like outcome.
All right, that's cool.
We can say
Well,
that we are the Zillow for energy.
I guess I don't remember talking about it, but I guess that confirms what you're doing. And it's a great way to
Yeah, I'm
explain it to people.
happy Shane, you mentioned it.
Great. Okay. Yeah, it's always fun to go on Zillow and go do some dreaming, figure out where all the billion-dollar houses are that we can buy after, or you can buy after you develop your software and save people billions a year and all that.
You were mentioning before, you said this is a complicated software for you to build, and I want to clarify, we are 7 people in the team, and in fact, I'm the only one not coding. Alan, my co-founder, he's a genius of tech. He has 14 years of experience in software development, and then we grew the team, adding software engineers like Sevi that also has a great background in energy. We have in the team an expert in renewable energy, Patricio. He developed more than 1 gigawatt himself of solar and wind with a team, of course.
1 gigawatt. Yep.
And then we have 2 people in the GIS and data side, Jose and Fernando.
Some of these terms we need to clarify. So CIS.
GIS, Geographical Information Systems.
Maybe we could just explain what GIS is too, because those are some things that people need to know.
Yeah, of course.
I know that people look at maps and GIS. My brother's a biologist and he knows about GIS and all that kind of stuff. And so it crosses over with solar. I believe you can look to see what kind of solar resource you have, things like that, probably wind resources. And maybe you want to explain a little bit more than I do?
Of course. GIS means Geographical Information Systems.
Geographical Information Systems.
Yeah, Geographical Information Systems. And I like to explain it as a sandwich of layers of data.
Yeah, sandwich of layers of data. That sounds like a good one. Yeah. And sometimes you even have people are familiar with Google does that with Google Earth and things.
Yeah, remember with Google Earth, you are able to select the layers that you want to see, like the streets, different types of layers, and you see it on the map. So GIS is similar where you program the tool, so you put the layers that you are interested in, And then you select the different layers you want to see on the map combined. So you can see the radiation combined with the lakes.
So I guess if you're doing the different layers of the sandwich and you're doing agrivoltaics, you can have a lettuce layer for your lettuce farming. And
So
build lettuce on the
it's like
sandwich.
that actually. So with the agrivoltaics pilot, we do consider different types of agriculture because you cannot do it with any type of agriculture. Yes, it is like that. However, something to clarify is that we are not a GIS. We are a proprietary data algorithm. But I was comparing to GIS what is more common for developers to use. The developers today build their own GIS tool, and they have their own geographical information systems that they use to find the locations. But
Right.
in these geographical information systems, you cannot check all the lands with all the parameters, weight the data, and find which is the best one. But it helps you to see all the data together to then manually find which is the best land that you think you will be more successful.
Great. Okay. Yeah, and I'm over here. I live in the California Bay Area. I was lived in Silicon Valley and Mountain View for a little while. And so I'm always around a lot of people that are techies and things like
Mhm.
that. So I get to be friends with them and see how they work. My girlfriend's in the other room. She's a senior data analyst, I think is what you say. So great. That's some pretty cool stuff that you're doing there. Let's see, back to the steps, perhaps.
Yes, the thing is also that you have different types of developers. You have the early stage developers, I call them that way, that they go from step one to step two or three. So they find the site, assess the site, and develop the site, meaning they get the permits and then they sell it. They
Hmm.
sell that project. And it depends the country and which stage and so on, but we can say that they sell it for $100,000 per megawatt.
Okay, $100,000 per megawatt, 10 cents a watt.
Yeah,
Hmm.
and it
Yeah,
depends where it can go to
something around there, just to
150.
for
So
around
also it can be $150,000 per megawatt. It's on
around,
the
and
same which
those
state.
are the early stage developers. And is that how you usually see it? It's not the same person or the same organization developing the whole project, but a lot of times it's just, or most of the time, it would be like early stage developers selling it to, what do you say, late stage developers?
It depends because
Mm,
then you have the late stage developers or utility scale
mm,
developers that what they do is they either develop from zero, they find the site, assess and develop, and then they, let's say, finance it, build it, operate it until they decommission. Or some of them, they buy from the early stage developers and take it from there.
mhm.
Usually they do both. They
Okay.
have a bunch of people bringing them projects, and they also have a team that have their own GIS tool to find the lands and to start from zero.
Okay, so
That's how
like,
it works.
so you say most of the time it's the same company that's the early and the late stage developers, or is it
It's tricky to say most of the time or not because there
some of
is
the
no
time?
data about it. You
Hmm.
don't know who started the project, where they got.
Uh-huh.
But at least as I know, maybe you can find some data from National
It's
Renewable Energy
it's
Laboratory,
might be
NREL, maybe
top
they
secret,
know,
yeah.
but I don't know at least.
Uh-huh.
But what I do know is that, because I talked to a bunch of them, is that the two ways are to develop these early stage developers that develop the first few steps and then exit the projects and they make money from selling projects, or the big companies, a lot of them are $1 billion companies, that they either buy from the early stage developers or develop from zero, and then their business is to sell electricity. So they operate the project for 25 years and they sell electricity, and that's how they make revenue.
Maybe a good early stage developer would be somebody that has good connections so they can have their brother-in-law on the planning commission, things like that.
For sure, there are
Little
cases like that.
corruption.
I mean, I'm Latin American, so I know what you're talking about, but let's hope it's all clean
Yeah, so
and
like somebody that has a briefcase with $1 million in it, that would be a good early stage developer.
maybe we are mentioning it's very simple, but it's very complex. You need to check all these layers, find the right site that makes sense in terms of finance, but also in terms of viability, and then close that site, get the permits, make the study. So your team, you need lawyers, you need engineers. It's
Hmm.
not that simple.
Yeah, sure. Yep. By the
So it is
way,
very complex, and that's why the big companies need them because they need
uh-huh.
to navigate these early steps.
And I was just going to say that, by the way, to the listeners, I was just kidding about the corruption part. Everybody can make up their own mind about that. I was just making a joke. Great. Okay. So let's keep going. And soon everybody that's listening is going to start using your software and become super successful.
Let's go in that road. Like to mention, like this is not just an idea, it's working. We are working with few companies. In fact, one of them is one of the biggest renewable energy developers in the world, a $1 billion company. And the other one is a very big company from Israel that develops all over the world. And we are working also with some other developers. It's not an idea coming out from a startup. It's a technology that is working and is adding value to some very experienced developers.
And is this something that you should mention or not? Like the names of
So
the big
I need
companies?
to ask them. So it's better
Okay.
not to.
Yeah. But we could only guess. Okay. All right.
Yeah.
Or somebody can contact you
Yeah,
at
of course. In
renewableenergy dot
private, I can
place.
mention it.
Great. Okay. All right. And so let's move forward here. Go ahead.
So we mentioned we were mainly talking about the first two steps, identify and assess. And what replace that is helping on those steps, which impact all the rest because like the next step is to develop and you need to get the permitting and close the landowners. And this will depend on which land you choose because depending on where you are, the permits that you need and also how many landowners and who are the landowners are basically the people you will need to convince to close the deal. And the same with the grid, it depends on the location. And after you develop it and you have the three main permits, you will need to finance it. So maybe you have their own money, like some of the huge $1 billion companies do, that they finance it themselves. Or you can get investors and finance it through a loan with the bank. And that's how you finance the project. After that will come the engineering, where you will need to also build the project, you need also to buy the panels and so on. And once it's ready, you start operating it. You run the project and you generate electricity and that's how you make money. You make money from selling the electricity. And after the project comes to an end, you decommission it and that's the life of the project. Maybe I skip some of the steps because I try to make it simple.
Sure.
There are more steps in the middle, but we are talking about maybe in average $100 million project that work for 25 years. So this is, I think, a simple way to explain it. In the middle, you have some alternatives, and maybe there is something called repowering that maybe in a later stage of the project, after 10, 15 years of operation, you want to change the panels for a new panels that are more efficient because of technology. It's getting better year after year. But this is the usual case. Like then there are a lot of cases in the middle.
And I'd like to think too that your system, it's working after 25 years. You have the crystals in the sunlight. Maybe you did change the modules a few years earlier. It can go on for a long time. If you just keep replacing things, it could last maybe forever.
Yes, let's say the permitting thing, the 25 years also depends on to who you sell electricity and under which agreements. There is something called PPA, Power Purchase Agreement, that
Yeah.
usually lasts 25 years.
So that's
So
the contract to buy electricity, the PPA, power purchase
yes,
agreement. Yeah.
but now we are seeing also a lot of projects selling directly on the spot to the grid, which is different. But yeah, one option is to do the power purchase agreement, and there are other options as well. And also the permitting depends, like also how much time the project can be in place depends on the permitting that they got. There are a lot of reasons, and not only the lifespan of the panels that define this lifespan of the project.
Great. Okay. Sounds pretty good. So thanks so much, Matias Sigal, and that is Sigal, not like the bird, maybe related. I'm not sure. Sometimes different languages spell things a different way. And I just thought I would mention how it's interesting how we met too. So we have a mutual colleague, friend, Paul Subzak, and he's like, you got to meet this guy. And we were both at the same conference, which was really cool. It was Intersolar in San Diego. And it was one of my favorite conference experiences. What was so neat, it was just like a nice day in San Diego, and it's a nice climate there in the winter. And you have this street, and you're going through the gas lamp district, and you're seeing all your friends on the street when you're walking back to your hotel and things like that. It was just a really great conference experience. And I think there was about 10,000 people there, maybe something like that, if I had to make a guess. I didn't count every one of them. I did a workshop. It had really good attendance. I did my workshop with Bill Brooks. It was a lot of fun. And anyway, I met Matias by coincidence. So out of 10,000 people, Paul is texting, and then this guy walks up to me and he's like, right after we were texting, and there you were. He just saw my name tag, and we went and we had lunch together. So that was kind of a neat way to meet each other. So I think it was just meant to be. Also, it saved some time trying to find each other because there we were at the perfect time. So it was really cool meeting you there, Matias.
Yeah, same, Sean. So yeah,
Mhm.
I agree. It needed to happen, and here we are also now making this podcast and sharing
Yep.
about our experiences. So I'm very happy that we
Yep.
met.
And another thing too is I know that you were raised in Argentina, which is a beautiful place. I've spent some time there before. And another thing is you live in Israel. And I know that you're in New York right now. So how long have you been outside of Israel?
Yeah, I was for a long time outside, so I had honestly a lot of trips for the work, for the startup in Europe and in the US, and I just combined all of them. So I went from one place to the other, and I'm from for a few months outside. I'm planning to go back soon. I hope the situation gets better soon. Maybe after the next event that we will meet next week in
Yeah,
Boston.
great.
So that's the plan. Honestly, I took it on the best way, and I said, okay, where is the best place for me to move forward with the company. And that's why I spent a lot of time in the US, in the Bay Area, meeting both energy companies and tech investors.
Well, great. Well, thanks so much for being on the podcast. And let's have you tell the people where they can find you. We
Yeah,
talked about your
so
website and things like that.
thanks. Yeah, a lot of fun. And I think I even learned a bit from the different base definitions that you shared. Thanks for having me here. People can find me on LinkedIn. It's Matias, Matias Sigal, Sigal. And that's the best way. I always reply to everyone.
Great. Well, thanks so much, Matias. And thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more about solar education, renewable energy education, go to Solar, SEAN, that's solarshawn.com, and get yourself a NABCEP certification. Or you can check us out at the NABCEP conference. I am the official PV associate provider for the NABCEP conference, which is coming up in North Carolina on March 18th through the 21st. It's always a lot of fun seeing all these NABCEP certified people in Raleigh, North Carolina, y'all. So check it out. Thanks so much, Matias, and thanks everyone for listening.